All right, everybody. So we are getting ready to go here with Tom Nook's wild ride here with Ninji, and so this is going to be a great talk. Do remember that the Q&A and discussion is all happening on Discord. There is a link in chat and also down below the stream. Once you get there, it takes us a couple minutes to get you all your roles, but just be patient or hit us up in the help and we'll get you all squared away. So with that, I'm going to turn it over, and here we are.
To talk about the new Animal Crossing, which is a game that you've probably heard of at least once or twice. It's been kind of popular lately. So I'm going to start off with the obligatory intro bits that every presentation has. I am Ninji, or Ash Wolf. Yes, that is my actual name. I'm 25. I live in sometimes sunny Glasgow. I just got a degree in computer science, and I like a bunch of things, including game hacking, which is what got me into this mess. And I also have far too much time on my hands, which is why I spent so long researching this game in the first place. There is a lot I want to cover in these 30 minutes, so here's a quick outline. So first I'll explain a little bit about the game, for those of you who have just been blissfully unaware about the concept of Animal Crossing. And then I'm going to talk a bit about the game's architecture, the tools required to rip it apart, and some of the techniques that I used to understand it. And in the final part, I'm going to talk about some of the gameplay mechanics which I researched. So essentially, what I'm targeting here is things which aren't listed in the official strategy guide for the game and which are hard to derive from empirical evidence or from testing, but which I still think are quite interesting. So first, the burning question. What is Animal Crossing? So this series started in 2001 on the Nintendo 64 and GameCube, and we're now on the 5th title, if you don't count the re-releases and the spin-offs. It's a fairly relaxed life simulation where you are the only human in a village full of animals, and you've basically got no goals other than paying off your mortgage. It's built to be a very slow-paced game where you just pick it up and play for a little bit every day, and the game world matches the real-world clock and seasons. You get random villagers like the famous Raymonds living in your village who you can build up friendships with. It's mostly single player, but you can visit other players over the internet. And it's also highly random. More on this later, of course. So it's very easy to play Animal Crossing casually, but if you want to be a completionist, that actually takes a surprising amount of work, because the game keeps track of what items you've collected, and many players try to max out these collections by getting every piece of furniture, catching every fish, and so on. Shops and visiting NPCs have items stock that changes every day or every week, like the screenshot of the Nook's cranny shop there. And many items, especially clothing and catchable creatures, have restrictions on when you can get them, like time or season. And you also get random events like gifts from villagers, like Sky giving me a lawnmower here, and hidden furniture that you get from shaking trees. And the game I'm going to be talking about in this talk is New Horizons, which came out in March when many countries were starting their COVID-19 lockdowns. And I don't know, I guess the idea of this idyllic little life sim just pulled in droves of people who wanted a time sink. There's still some faded ads all over my city from when the game launched. It's the first mainline Animal Crossing title since 2012, and it's the first one that Nintendo is handling as a service, so to speak. So it's getting regular updates, and it's getting regular changes to the gameplay for balancing. And there's also tons of telemetry about how people play the game, which I'm sure is informing the changes they make, as well as what gets added to the game. But what really drew me into reversing this game is that the series is full of invisible game mechanics, which I was really curious about. So if you look at a game like a puzzle or a platformer, there's really obvious and understandable rules. But in something like Animal Crossing, all of these rules are kind of obfuscated so that the game world and the NPCs feel less artificial. So you get some things of surprising depth, like flower breeding, which uses Mendelian genetics. Then you have these weird mechanics like villagers having conversations and your island getting a rating. And I kind of wanted to know what logic underlied all of these mechanics and how I could bend it for my benefit. So if you want to actually get anywhere with looking into this game, the first step is just looking at the data. So I started with an xdump tool, which is Switch Homebrew, which will take the files from a cartridge or a digital game, extract them all, and place them onto a microSD card. And the result gets you two main parts. So first, there's the exefs, which contains all of the game codes and libraries. And this is a Switch-specific format, but that's fine because it's all been documented. And then you've got the ROMFS, which contains all of the game assets. And these are mostly Nintendo-specific formats as well. But thankfully, most of these show up in other games and have existing documentation and tooling. So next, I'll tell you a little bit about the game architecture. This game is built on Launchpad 2, which is an internal engine that's shared between various other first-party Nintendo games like Splatoon, Mario Maker, and ARMS. There's some common libraries that show up in it. So there's NintendoWare, which has been in hundreds of games since the Wii, so it's very well known and well studied. There's Havoc, which is well known for physics, but this game just uses it for visual effects and not for any of the actual gameplay physics. And there's some internal libraries which only seem to show up in first-party Nintendo games. So there's EventFlow, which does scripting. There's Message Studio, which is for localized text. There's SCAD, which is a C++ utility library. And there's Xlink, which does lots of stuff with sound and particle effects. It's quite boring. There's two formats I'm going to talk about in more detail because they're actually quite relevant to the game logic in Animal Crossing. So binary YAML is as cursed as it sounds. It's shown up in a few other first-party Nintendo games like Breath of the Wild and Mario Odyssey. And New Horizons uses it heavily. So there's lots of binary YAML files with configuration parameters, all sorts of things like the radius of an NPC's personal space, or how long they will take doing one activity, or the strength of falling rain. There's lots of repetitive templated C++ code for dealing with these files. And I can't confirm this for sure, but I suspect that internal debug builds of the game have an interface for these that lets the game designers tweak these parameters without bothering the programmers, because there's stubbed out codes to save the files, and there's also Japanese explanations for many of the fields, which are never actually used when you're playing the game. There's also lots of metadata for the engine about stages and rooms, and there's the save file schema, which I'll touch on later because it's extremely useful. There's some helpful tools for dealing with these files, courtesy of the Breath of the Wild modding community. The main hurdle with these is that most of the keys in the binary YAML dictionaries are stored as checksums of the names rather than readable text. But this is quite easy to bypass because all of the original names are in the executable, so you can just go through all of the strings that show up in it and build a lookup table. The other format I want to go into depth about is binary CSV, which is even more fun. I've only ever seen it in this game. They showed up in Mario Galaxy, but the implementation in that game was very different. So these have lots of tabular data about the game, things like building themes and items and NPCs. Some of these have thousands of rows. They have a very simple structure. It's pretty much just the version number, the amount of columns and rows, and then the offsets and the keys for each column. The keys are also checksums, like with the binary YAMLs, but with these, we don't get the original strings in the executable, which makes things a bit harder. We don't know the types of the fields either, but we can make guesses from the size of the field and the contents. So I struggled with these for quite a while. But helpfully, GitHub user ZBanks took my limited research and did some very ingenious stuff using weaknesses in the CRC52 algorithm. So they were able to track down certain aspects from some of the very similarly named columns, like some of them being a month followed by 9 bytes, and those bytes were always the same. So this info was enough for me to make some informed guesses. So I figured out the naming scheme for these, which was basically just name space type. So I used hashcats to brute force most of these, and that gave me lots more information about the data files. There was one challenge left, which was enumerations or string refs, which is what Nintendo seems to call them. So instead of storing indices for things like 0 meaning red and 1 meaning blue, these just store the CRC52 of the string like red or blue. And weirder yet, each of these columns has 2 lists of possible strings, one in English and one in Japanese. So you can see some examples there from things like seasons. And a flag in the head of the file determines if that file uses hashes of English or hashes of Japanese. The game goes through every row in the file and caches the indices for the columns. So I used this to my advantage, and I wrote a Ghidra script which looks for every instance of this code, dumps out the lists, and dumps out which columns they are linked to. And with that, I was ready to access the files. So here you can see one sample, which is the event flags player activity file. So this one lists all of the different metrics that the game tracks about player activity. And these are used for your villagers to talk to you about things like, oh, it looks like you've been cutting lots of trees, or it looks like you've been placing lots of paths. And each of these rows maps to one of those metrics, and you've got readable names in English and also descriptions in Japanese, which the developers used. And then here we've got the item size file, which is another of these files. So here you've got some interesting unused fields, like the rest size limits and the polygon limits, which I think are just used for internal use, maybe by debugging versions of the game. Maybe they've got some testing metrics where it goes, hold up, you've got too many polygons for this item size, tone it down, because these fields are never used in the actual game. There's some weird things about this format which I'm not sure I'll ever understand without seeing the actual source codes. So there's columns that the game never looks at, like those I just mentioned in item size. There's these capture fields which seem to control the generation of pre-rendered item icons in the user interface. I'm pretty sure these are just generated as part of the build process. The use of the string refs versus just plain old integer indices is really inconsistent, because sometimes one kind of data will be stored as a string ref, and sometimes it gets stored as an index. And you even see this happen across columns in the same file, like color 1, color 2, color 3, and color 4 being different. And the C++ implementation itself is quite strange. The same BCSV code is repeated for every file, which makes me think it's just a C++ templates class. Some files reference rows by integer keys, some by index, and some by string. And there was one version of the game with a bug caused by a developer mixing these two up, where they tried to pull row 3 out of a file which was indexed by the unique IDs, but there wasn't a row with a unique ID 3. Row 3 had unique ID 4. And to finish off this section, I want to mention a few other important file formats. I'm not going to go into as much detail on them, because these are all quite standard, and you can find tools for them quite easily if you just throw the file extension into a search engine. But I still want to mention them, as all of these include lots of relevant data in this game. Compression duties are split between SZS, which is a Nintendo algorithm dating back to the GameCube, and Z standard, which is quite recent and open source. Archives, models, UI layout, and text all use common Nintendo formats. And event flow scripts have some really handy tooling from the Breath of the Wild folk. But I'll go into that in a little more detail in the next part. So what next? I did promise some decompilation, so that's what this part is going to be about. The tool I'm using for this is Ghidra, which is the reverse engineering suite that the NSA released to the public last year. If you use it, I highly recommend building the latest version from Git, because the stable release 9.1 is missing lots of important bug fixes and optimizations. Loading the switch files is really easy with a third-party plugin, but the biggest issue with this game is just, how do you analyze over 50 megabytes of codes? Like, this game has over 166,000 functions in the current version, It's not Java or C#, so you don't get the helpful metadata and the helpful structure that these runtimes give you about things like class layouts. There's nothing splitting apart methods from one class other than their vague location in the code. And there's no symbols, so almost every part of the code has no names. You get some imports from libraries, but those are a small minority. So what can we pull information from that will help us get some more hints about this code base? So Splatoon 2 is one of these. For quite a while, Nintendo didn't bother stripping the binaries in Splatoon 2, so it just shipped with names for every single function and every single global variable. It uses Launchpad 2 as well, and most of the same libraries, so there's lots of shared code between these two games. And using Ghidra's version tracking, you can correlate together similar functions that have, say, identical code or very similar codes, and you can confirm these matches and port these names over. It's not perfect, but it's better than nothing. One of the issues is that sometimes, because of compiler changes, the same source code will compile to different assembly, so it won't match up properly if you just do a naive match. And sometimes libraries will just evolve over time. So for instance, even though both of these games use Launchpad 2, the actor system has completely changed in New Horizons. And some aspects of C++ are just a pain in general with these approaches, because things like templates and virtual functions can generate assembly which looks very similar at first glance, but is actually not the same. Another tactic is the event flow scripts, which I mentioned earlier. So these are flowcharts which control many aspects of the game logic, including all of the NPC conversations. And these are absolutely amazing for reverse engineering. So each of these flowcharts is just a series of events. These are formed of query and action nodes. So the queries are conditions and the actions are things that the game wants to do. And all of these are named using fully readable English text. So all of these queries and actions exist inside of the game executable. But the great thing about this is that it's really easy to just find the code corresponding to one of these. So if you look at query and special weather and you see that it's accessing one particular singleton class, then it's quite a safe bet that this class and the data it's accessing is going to be related to the weather. And you can also look at what the event flow does with that return value to figure out what those return values mean. So this is just amazing for figuring out more systems in the game and getting more of these hints that you can piece together. Another really useful source of information is the save data, because it's the canonical store for lots of information about the gameplay. This is built out of 5 pieces, and each of these is a massive fixed length block of data which gets encrypted and written to a file. So this game is being updated regularly. What happens when Nintendo adds new features and changes the size and format of this big ass block? They just migrate the data. And the way they've done this is by storing the schema for every version of the game. So this file contains info about all of the types and all of the fields, identified by hashes of their names, again. But thankfully, the outermost call to this migration code uses the plaintext name for the root structure, and this leaks the naming convention for the structures. So using this, I was able to do lots more brute forcing and figure out many of these names. So I wrote a hashcat kernel for murmur hash free and did lots of brute forcing and eventually figured out most of the structure. I'm missing the names for some fields, but I've got the vast majority of it. And you can see an example there from the root class, the root structure for islands data. So these approaches give me tons of information, but collating all of this together is still quite a struggle. I automated tons of this by writing Ghidra scripts for repetitive tasks. So I gave every class that had virtual functions a unique name with the prefix CQ to speed up the process of disambiguating them. So for instance, the base interface class for strings was named CQ clean pecan until I figured out what it did and gave it the nicer name of text base. I named all of the handler classes for event flow queries and actions because I had the real names in the flowchart files. And then I did the same thing for the BCSV classes and the fields caches. I did that for the actor classes as well because they have debugging methods that leak the official names. And I built Ghidra data types as well for things where I had info that I could process automatically, like enumerations where they'd leaked the strings for some reason or other, or the save data structures from the schema. But even with automation, this game is a pain. Like, this is possibly one of the hardest binaries I've tried to reverse. It's not obfuscated on purpose, it's just really complex and over-engineered. So there's hundreds of identical template classes that control multi-threaded access to the save data, one for every single structure. The text processing code has this complex hierarchy of classes just for really simple text operations, which in most string libraries will just be one method. There are certain code patterns which show up all over the place in this game and just hit weak points in Ghidra's decompiler and generate really ugly code or sometimes just break it entirely. And the frequent updates make the whole thing a pain because each one includes a new executable where everything has moved around. The version tracking in Ghidra helps, but you still need a lot of manual work to get accurate results. But even with all of this, I managed to learn a lot about this game. So in this part, I'm going to talk about some of the game's mechanics. I had a hard time picking which ones to talk about because there's just so many of them. But I decided to go with stuff that wasn't well known and which isn't covered at all in the official strategy guides. Because, might as well pick something more interesting to shed some light on. So the first thing I'm going to talk about is villager mail. This is based off research I did a couple of major updates ago because I've not ported these annotations to the latest version yet. Every version of Animal Crossing has allowed you to send mail to your villagers with text and a gift. And sometimes you will get a reply. But how does this actually work? So the game grades your letter. So this process produces an analyze type, that's what they call it according to the save structure, a score, and a friendship penalty. So if you send a gift, then the villager puts it into their inventory. They might show it in their house if it's furniture. And the result of this process goes into the array that's called mail receive info. On the next processing cycle, they look at that array to determine how they're going to respond to it. And if you send more than one piece of mail, the score determines which one they'll respond to. But what actually goes into this grading? So I put together this massive table of the rules that the game uses to grade your mail. So you can see at the top there's these two conditions where if you curse too much, going by the inbuilt switch world filter, or you send them trash gifts, then you lose friendship points and they blank you. There's the 3 purple rows, which are birthday, move-in, and winter checks. These are for special kinds of mail which only trigger on certain dates, and I'll explain these a bit more on the next slides. And then on the bottom 4 rows, those are kind of the catch-all options if you don't meet any of the other conditions. The game checks your message against a list of n-grams for English or whichever language you're using to try and determine whether what you've written looks like plausible, real text that somebody might write, or if you're just key bashing. But regardless, if you write 11 or more characters and you use at least one of the valid n-grams, then you should always get a reply of some kind. So special mail types. The birthday, move-in, and winter grading is interesting because the game tries to determine whether you're talking to the villager about that topic or about something else. So there's 3 lists of n-grams in each language for each of these 3 topics. The game counts how many of the n-grams appear at least once in your message and uses these rules to give a probability. And there's a slight boost to that probability if you include the villager's name or the island name. And here are the English lists for birthday and for move-in. So you can see how this includes words you might expect to see in well wishes for those events. So in birthday, you have the start of words like hap, birthday. And then for winter, you have the start of all the years from 2010 to 2059, because you might include those in a New Year's greeting. And last comes the reply phase. Unfortunately for all of us, Nintendo has not integrated GPT-3 into this game. All of the replies are just pre-written by the developers. They come from a number of pools split across the 8 villager personality types, and each analyzed type has a pool within that set of types. So for example, all of the short replies reference you sending a very short message, and all of the long replies reference you writing something really long and them going through the effort of reading it, or saying that it looks like you care about them a lot because you've written so much. The special analyzed type is a little bit different because it looks at the kind of gift that you sent and picks a message based of that, like thanks for the flowers or thanks for the furniture, but I already have this. And there's a couple more special cases. If you send multiple mails in one day, then there's a chance you'll get the max reply where they talk about how much you wrote. And for some of the types, there's a chance of them sending you a gift back, which varies depending on your friendship with them and where you included the gifts. So in this example on the right, I got a gift from Raymond. It's very interesting. I guess interesting is one way to put it. Another mechanic I want to touch on is the furniture variations, which is something just added in New Horizons, the latest game. So many furniture items have variants, like wood colors or painting types, but you can only customize items that you craft yourself. For items that you buy from the shop, you cannot customize them. You're just stuck with the variant you got when you bought that item. And the game pushes completionists to get all of the variants for each of the items, because this gets tracked in the item catalog. So not only does it track whether you've gotten, say, the fragrance diffuser, but it also tracks whether you've gotten each of the variants that are available for that item. So each item has what I call a native variant for a given island. And depending on how you buy it, you might be guaranteed the native variant. You might be guaranteed a variant that is not native. Or you might just get a random one, irrespective of whether it's native or not. And some items are only available in the native variants. So if you want those items in a different color or style, then you have to trade with other players who have the variant you want as the native one. But what actually determines this? This has been hotly debated in the Animal Crossing community. So there was this post on Reddit a while back from user Praise Holo, who said that the color of the airport on your island determines the native variant for the exclusive furniture that you can buy from the Nook stop machine. So here you have this ridiculous chart of all of the different types, and on the top 4 you can see there's blue airport, orange airport, green airport, yellow airport. Kind of correct, but sadly correlation is not causation. The save data includes this structure called save item marketing routes, and this contains a field called village lot ID. And this is a random value from 0 to 99, which gets picked when you create your islands, just completely at random. And as it turns out, the native variant for each item in the game is just computed via a really simple modulus formula, which takes into account x and m. So m is the amount of variations for the item, and x is either the item's ID or the column in this file that gets called item random color group. And this is used to make sure that certain sets always come in the same variant. So, for instance, the antique furniture set is always in the same variant, even though each of those items has a different unique ID, because the random color group they assigned to it takes precedence over that. But how does this tie into the airport color theory from the Reddit post I showed? It's not wrong, but it's also not fully right. This is actually based off the native variant for the DAL model plane item, and that determines your airport's color. So on the right here, you can see my annotated decompilation of the function that picks the airport theme color. So it creates a structure with FTR DAL figure, which is that item. It calls the method I called static adjust to native rebody, which picks the native variant. And then it takes out the variant ID it picked and it stores that as your airport theme color. And the other field in that structure, the village marketing type, is a little bit less interesting. It just controls the appearance ratios for the 4 wallpaper and flooring categories that you can get from Nook's Cranny. I can't talk about Animal Crossing reversing without mentioning turnips. You buy turnips on Sunday mornings, and then you get 6 days to sell them before they rot. If you're lucky, then you can sell at the right time and make a huge profit. So there's 4 patterns in this system, unofficially called small spike, large spike, fluctuating, and decreasing. There's still a fair amount of random variance within the patterns, but these just reflect overall trends. So for instance, the decreasing pattern will never let you earn more than what you paid. You'll always lose money. But large spike allows you to earn up to 6 times as much as what you paid if you're lucky. It was really easy for me to find this code in the game because it just references 2 event flags by plain text string, which contain kabu, which is Japanese for turnip. So I manually decompiled this algorithm into understandable code. I dumped it on Gist and tweeted it. And then a ton of people built tools around this, like turnip profits. Another of the things I looked into was the weather system, which is really interesting because it's interesting from a visual standpoint because you get things like rainbows and special clouds during certain parts of the year. But rain and shooting stars also influence gameplay because rain will water your flowers and shooting stars will let you get star fragments, which are useful for certain kinds of items. And unlike most random aspects in this game, the weather is actually derived from a fixed seed, which is specific to islands. And the game combines this with the date using a simple formula. The result seeds a random number generator, and then the output is used to decide the weather you see. So there's 33 unique daily weather patterns with probabilities for each date of the year, like rain 03, rain 04, fine 04, which is like good weather, rain clouds, fine rain, and so on. And the cool thing about this is that if you get enough observations of the weather, because by observing what patterns you see, you can pin down what output you're getting from this algorithm. And if you pin down enough of these, then you can actually brute force which of the 2 billion seeds is going to give out the data you've seen, and then you can predict the weather that you'll see for any date. So I built a web app for this called Meteor Nook, which has become kind of popular. You can check it out if you want. It's also open source, so you can see how all of it works. I wish I could talk about more of this game, but time constraints are a thing. So I'm going to cap this off with some trivia about a couple of interesting bugs in this game. So there's this mechanic where you will get one glowing spot on the ground every day, and you can dig it up to get a bag of bells, money. And there's supposed to be a tiny chance that you will get 10,000 or 30,000 bells. Normally it's just 1,000. And here you can see a snapshot from the strategy guide which confirms that. So it says on rare occasions this can happen. I think they intended for this to happen only after you've built a house, because in the beginning phase of the game you just have a tent. And on the right you can see the decompiled code that does this. It checks to see if your house has the flag called House Order 1 set. However, this flag is only set in one small period of time. It gets set when you ask Tom Nook to build your house. The next day, your house gets built, the flag gets cleared, and that flag will never be true again. So, end result, you can never actually get this bonus. The fix would have been to check the house level fields in the player house structure instead. I guess they just never caught this because this is just a small bonus. It's not like an exclusive item that people will notice missing. No one will think, oh, I've never seen this bonus. They just think, oh, I've just been really unlucky. And another fun bug, the most recent update to the game, 1.4.1, removed the files for the sumo ring flooring from the file system. I have no clue how this happens. How these files just disappeared from the file system. I'd love to know what in their build system caused this. Here you can see a couple of screenshots where The flooring is just showing some random texture from the wall. On the left, it's the fireworks from that weird fireworks wall, and on the right, it's a window. I'd love to know what caused this. I don't think I'll ever find out, but it really makes you wonder. Like, the build system for this game is so automated that they're actually generating these thousands of icons automatically, but yet you can get this mess up where the resources for one item just disappear? I don't know. But I'm going to cap this off here because I'm already over the time limit. So that's it for now. I hope you enjoyed this talk. Games are hard to make, but it can be quite fun to know how all of this stuff works and what logic goes into all of these weird little mechanics, like villagers reading your messages without actually reading them. If you're curious about some of the stuff I talked about, like the save data schema I discovered and cracked the hashes for the names in, and the Ghidra scripts I wrote, most of this is up on my GitHub at tricky/cylindrical earth, which is a reference to the weird perspective the game's camera uses. But thank you for listening. Please feel free to ask questions in the Discord channel. Okay, let's see, questions. So, Astro asks if there's a way to find or calculate a village lot ID without save dumping. So there's only 100 possibilities for this, which means that you could pretty much use a similar technique to what Meteor Nook does with brute forcing. So if you observe enough outputs from this process, then you should be able to just pin down one of them uniquely. I think you can probably do it in like 5 or less, just because there's so few possibilities, and every item that has a different amount of variance is going to have a different modulus for the algorithm. So each of those is going to give you a little bit more information that will let you find the ID. So it should be trivial to figure out. I've just not gotten around to doing it. So NAK today asks why neighbors rarely ask for favors in this game. I've not really looked into this all too much because the system that controls villager behaviors and AI is incredibly complex. I put some work into trying to figure it out, but I got kind of overwhelmed because there's just so much that goes into it. What helped me out with reversing a lot of the aspects in this game was things like the save file schema, where I have official names for all of these fields, and so I can often see which bits of data a particular bit of the code is looking at. But the villager behavior is a little bit trickier because all of this information is kind of transient. All of this happens mid-gameplay, but none of it actually gets saved to the save file across different sessions of the game. So as a result, I don't actually know the names for any of these fields or any of these options that go into it. And that just makes that part of the system a lot harder to look into. What else? So Carlo today asks about money trees. Is it random whether a tree is allowed to give you more than 10k bells per bag? Yes. This is something that people keep on sharing old wives' tales about online, but this is something I tweeted about months ago, and this is also something which the official guide to the game explains. It's fairly simple. If you bury 10k or more, then there's a 30% chance of the amount you buried and a 70% chance of 10k. And there's similar rules for the smaller amounts. So if you bury between 1k and 9k, then you have the same thing going on where it's 30% what you buried and 70% just 1k. Kalu also asks if there were more variations in neighbor dialogue in the previous games. I'm not actually sure. People say, like, I've seen lots of people whining about the lack of dialogue in this game compared to previous ones, but I didn't delve into any of the previous ones into this extent. I played Wild World casually when I was like 13, but that's about it. And there are things they've added in this game which just weren't a concern in the previous ones at all, like villagers commenting on the furniture around the islands, which wasn't a thing in the previous games because you just couldn't place that furniture around the islands. So Jamie Sharp asks, like, what I would like to see change in future games and what stood out as novel and awesome. That's actually kind of hard to answer. I do want to see them place a bit more focus on the customization aspects. There's some really obvious missing pieces in New Horizons. Like, they've expanded the limit for design patterns, but it's still tiny, which limits how many custom designs you can have for things like paths. And I really also want to see them expand the customization for buildings. So I'd love to be able to theme the buildings which I have to have on my island. And I'd love to design my own buildings as well. There's lots of furniture that could go well in indoor settings for things like cafes and restaurants and offices. But putting it inside your house doesn't make much sense. And putting office things outside on the island doesn't make much sense either. Oh, NAK also asks if the internals of this game give me the impression that the added features were really unfinished, or if they always planned to trickle the features out like this. I think it's a combination of both of them. Some of these things, it's obvious that they've been working on them over time. So there's features they've added where there were leftover strings in the initial release, but when they actually added that feature, they've changed aspects of them by, say, adding more bushes or adding more creatures. They recently added the Dream Islands feature, and the evolution of that was quite interesting because the structure for that feature has been in the save file since launch, but they kept on adding more fields to support it. So I think the first version just included one identifier, and then they added a couple more fields controlling the online functionality for it. And then they added even more of them for dealing with user content reports. So it's been obvious that these things were not held back just for the sake of holding them back, but they were actually unfinished. And I also think that part of this stems from what I mentioned, where they're developing this game as a service and using the data they get from telemetry to inform development. So every time you do lots of things in this game, like talk to a villager or buy items, that sends play reports back to Nintendo. So I have no doubt that Nintendo is using these to look at how people play the game and using that to manipulate, say, the ratios of things that they add in future updates. Maybe how much time people are expected to spend on a particular feature, or how much time people are expected to spend to collect all of the items in a set. And there's been quite a few instances where they've balanced the game by, say, changing the probabilities of certain mystery islands, or by changing the rates at which certain visitor NPCs arrive in your islands. And there's still plenty of hints for things that look like they'll be added in future updates. They've definitely gotten better at hiding some of these leftovers and putting if-left checks around more of them so that I don't tweet about them, but things still slip through. But I'm going to hand this back to DC first for now. Actually, one last question. Chloride Skull asks, what's the oddest thing I've seen in the code so far has been? The oddest thing, so I did tweet about this once, but my favorite thing I've seen in here is there is an actual poop joke that survived compiling. There is a function on the item class which takes one of the unknown fossils and assesses it. And if you call this function, then if you call this function on an item which is not an unassessed fossil, it returns coprolite, or poop, which was just hilarious to me. This is a poop joke that is in the code and has managed to survive compilation, and I've managed to see it. Like, I love that. Alteza asks, is there a list of amiibo values that Animal Crossing accepts? Yeah, this is in the amiibo data BCSV table. It does not have any amiibo values for unreleased amiibo. But that makes sense to me, because it's one of the easiest things for Nintendo to strip out. So even if they are working on these amiibo, then they almost certainly have these behind flags so that they won't make it into the release game until the amiibo themselves are announced. And Cat T asks, can I talk about the Dream ID to Island Seed link? That's quite straightforward. The Dream ID lets you get the data from islands, so if you get that, then you can observe the weather on the islands, because your Switch gets that whole island file and looks at it. And that contains the seeds because it needs that to calculate what weather and what shooting stars you're going to see when you are playing inside of that dream island. Yeah. I think that's it for now. Thank you all for listening. Thank you for asking questions. I hope you've enjoyed it.